I was reading something. In the name of later.
I'm your bigger student, right?
Yeah. No.
You don't want to talk to me after last night. Oh yeah, we are. Monday, October 10th.
Oh yeah.
And then we also take them Tuesday too. You don't like anybody. Mr. Alex the liar.
What?
You like me.
What do you mean?
You said you were gonna be on, and then you said you can't.
Yeah, I couldn't.
Lie.
No, because we were buying stuff. I wasn't even at home. I was at the hotel.
What would you buy?
Groceries for my mom. She wanted to make egg rolls.
Egg rolls. Oh, that sounds good.
Because I was like,
Are we gonna move the desk?
If you just shut up, oh Jesus Christ.
you should get
Saturday,
on
though.
tonight.
Saturday.
Saturday work.
Who's so?
Oh, we're all getting on
No.
Saturday?
Show us skills.
You're gonna show us some skill? He's at your
Too bad I won't be on
You're
Saturday.
failing.
Trick shot. Are we gonna move the desk back?
Yes, please, sorry. Sorry, my last class had a test, so. Okay, today, I know that we had homework due. I know we had homework due on Monday. That's that worksheet 2.6, not 2.4. It's 2.6. That's the one on you had to create numbers that fit a certain parameter for those divisibility tests, right? You'll have time after lunch to work on that just for a little bit. Our major topic today is section 2.7, so you'll need your notes today. So section 2.7, we're dealing with prime factorization today. Okay, we have a couple different topics I want to discuss. Number Number one, we're going to talk about factors again. That's going to be one of our major topics. That's a part of this, the root word here. Okay, we're going to talk about factors. And in that, we're going to talk about factor trees. That was one of the topics we've already previously discussed, and I want to talk about it. A factor tree. Okay, then our major topic we're going into is prime numbers versus composite numbers. That's going to be our major topic. We have discussed these before, but I like to talk about them, so the prime numbers. And other than prime and composite, our last topic here will be prime factorization. So that's going to be our major goal thing. We'll do a couple examples of those. So that's kind of our outline for today. So let's write that down. Again, after lunch, if you need to, I'll give you a little bit of time. You can work on that worksheet one more time. We have not finished that. Okay, let's jump right in. Let's talk about this first topic, factors. Let's do that first. And what do you remember about factors? We've talked about this word before, but why? What do we use it for? What are factors a part of?
See how much one number will go into another.
Close. You're actually really, really close. You're on the right page.
It's like the factor tree.
Kind of like factor tree. It's got that in it, but what are factors to begin with? How do they apply to the tree?
Like 1 goes into 20. Wait. I think I'm
If you guys mix your definitions together, the idea is factors are numbers that multiply. Numbers that multiply to give a product. So what I mean by that, they result in a product. It's numbers that you're multiplying together that are in different combinations to make a larger number, right? So it's kind of like what Andy you were trying to explain. There are numbers that go into something, right? That's the idea that you're breaking down. And just like Alex, you were saying, like 1 and 20, those go into 20. But there's also other factors. We're looking for every combination that can multiply to give a product, a certain number. Remember, the word product means to multiply, but it's the result of multiplying. It's where we multiply factors together. That's the idea. So it's numbers that we multiply. Numbers. There we go. All right. Now, the one topic we did talk about was the factor tree. That was one of our things we did. So I'm going to actually use the number 20 like Alex you were saying. Right? So the number 20. Right? When we do a factor tree, to me it looks like a Christmas tree. It looks like an evergreen tree. It's like this, right? It looks like an evergreen tree if you're really bad at art. There's my little Christmas tree. Right? All right. But you're looking for every combination of numbers that can multiply to give you 20. Those are factors. So, Alex, what was the first one you were saying? 1 and 20, right? Those are factors of the number 20. Okay? Is there another combination? 2 times 10. And is there another one? 3 won't go into it. 4 does. 4 and 5. And there's no number between 4 and 5 that's a whole number, so we're done. That's where we stop. Again, how I usually make factor trees, I check every number 1 through 7 until I get to numbers that are almost the exact same as I go. And 3 we threw out, so we don't write it. Those are all the factors of 20. Here's the weird thing. We're not doing factor trees today. We're not doing that. So get that out of your head. We're doing something that looks like it, but it's not that exact thing. Okay? All right. Make sense? Okay, so that's what we've done previously. That was, I think, actually the very beginning of Chapter 2, in fact. That was the first section of Chapter 2, Section 2.1. Okay, now, get into this idea of prime and composite. We're going to need this topic to help us out why this is going to be different today. All right. Let's talk about prime numbers versus composite. Composite numbers. Okay, we'll start with prime. Prime numbers, when you're actually breaking down primes, they can only be broken down into one and the number itself. So when I'm talking about that, it is a number. Yeah, that's a good example. It is a number that contains only two factors. It only has two unique factors. I should put that in there. Two unique factors. So the result would be 1 and the number itself. So the number 1 and the number itself. So a good example would be like the number 11. I'm going to put that on the board. Your example is the number 11. If you're doing a factor tree, only 1 and 11 go into it. There's no other combinations. 2 doesn't go into it, 3 doesn't go into it, 4 doesn't go into it, so on and so forth. Okay, there's other numbers. Now I'm going to give you that list of prime numbers here. Okay, so the list of prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, so on and so forth. I don't think I skipped any. 9, 8 don't go into it. 12 doesn't, 10 doesn't, 15, 16, no, 18, no, 20, 21. Okay, so those are the prime numbers. Now notice, what number did I leave off of that? Right in the beginning. 1. Most people are like, well, isn't 1 a factor? Isn't 1 prime? Oh. It's not, it's actually neither of them. It's neither composite nor prime. The reason why, when you break down the number 1, 1 only has 1 and itself. But that's only one number. It's not two unique numbers. So let me give you the idea here. And the number 1, when you break down the factors, is 1 in itself. That's the same number. It's not two different numbers, two unique numbers. So this is not prime by definition. By definition, doesn't fit. So it's that weird number because one only has 1 factor. Okay, questions with primes. All right, now, if we go to the definition of composite, it is a number that contains more than 2 unique factors. Has more than just 2 factors. So it's not just 1 in the number itself, there's actually another combination of numbers. So it would be 3 numbers, it could be 4 numbers. So it's basically, if you want to think about it, it's all the numbers I skipped. So what were some of the numbers I skipped in that list? 4, yeah, I can't use 1. So 4, 6, 8, 10, oh actually 9, 9, 10, or 12, 14, 15. You see all the numbers I skipped there. And they keep going, right? There's more than just those prime numbers. There's more than just these composites. These are just the ones I remember, right? Because if we do an example here, we do an example of, let's say like the number 9. I do the number 9 here, okay? Even though most people think it's odd, so it can't work, it still has numbers in it, right? The numbers 1 and 9, and then what's the other combination? 3. Well, that's more than 2 factors. The 2 factors are 1 and 9, but the other numbers are 3. So I mean, that, yeah, there's no other numbers because they're 3, 4, right? But there's 3 factors there. they're constantly finding new prime numbers every single day. There's this weird quirky little rule for finding prime numbers that fit a certain stipulation. That's something if you go to like an upper level college math class, there's some generic way to actually calculate what the next prime number is using the previous ones. It's kind of a little quirky thing because it is a sequence of numbers. So that's just what you need to realize. All right, but let's keep going. All right, so our goal today is to do prime factorization. So let me write that on the board. Prime factorization. Okay, what this is, big fancy word for basically we are going to break down a number into prime factors. Prime numbers or factors. Okay, I'd like to write that down. This is a little more difficult than you think it is. So that's why I really am trying to state how to do this correctly. So breaking down a number into prime numbers only. It is not a factor tree. I need to warn you of that. In fact, I'm going to put that in red. It is not a factor tree. Despite what it's going to look like, it's not. There are certain rules for how we do it, so I'll kind of show you as we go. Okay, we're going to start with that first number that we did earlier. We're going to actually start with the number 20. That was the one that Alex brought up earlier. So this is going to be our first number. So what I want you to do, put 20, and I want you to put a box around it to signify that that's the number we're starting with. All right. So if you read the instructions, or read the actual definition here, we're trying to break down that number, 20, into only prime digits, prime numbers. Now, look at that list over there. What are my prime numbers?
2, 3, 5.
All right. Yeah, you already got the numbers down, right? We're going to try to break it down into only those, not the composites. Okay, that's weird. So what's my first prime number on the list? 2. We always check that first. So, does 2 go into 20? Yes. So what we're going to do is, since 2 does go into 20, we're going to separate. What do you take times 2 to give you 20? 10. All right. Now I know that you're probably looking at yourself and you're like, well, that just looks like a factor tree. We didn't use the number 1. Agreed? We started with a 2, which is weird. And if 2 didn't work, we tried 3. 3 doesn't work, we tried 5, and so on and so forth. All right. Notice I want the prime number on the left. And if there's any other number on this side, this number over here is typically where you put your composite number. Okay. I want the composite number over here. And the goal is, we're going to try to break down this side as far as we can until you get down to just primes. That's the idea. So over here, we have the prime number. I'm going to ignore this number for right now. Because right here, is this number composite? Yes, we have to keep going. We have to break this number down, not the 20, this number. So we're going to go further. So it's like we're starting all the way over again. All right? So we're starting. We're going to the next rung. We're going to start with 10. What's the first prime number I should always check? 2. Does 2 go into 10? Yes. How many times? 5. Any whole number here? 5.
Oh.
Okay. 2 times 5 is 10. Okay? Now, so I put the 2 on this side, the 5 is over here. Is this number prime? Do we end with a prime number on this side? Yes, we're done. This is the prime factorization of the number 20. Now, how this works, what I'd like you to do is, now that we ended with a prime, you were going to draw this big looping circle, starting with the 5, because that's the number we ended with, and you're going to draw this big looping circle, circling all the prime numbers that we had. To me, it looks like a tube sock or a hockey stick. Okay? In this case, kind of looks like a weird blob.
Don't you take like 2 times 2 and then times 5?
Yeah, so that's the idea. So in the very end, so does everyone see what I circled there? Only the prime. I would like you to write down below it, I want you to write just what Corey you were saying. 2 times 2 times 5. That right there is the correct prime factorization of the number 20. We've broken down 20 in only primes. And if you were to actually use a calculator and multiply those numbers together, I don't want you to do that. But if you were, guess what number it would come to?
20.
20. That's how you know you did it right. But we're not done yet. This is where it gets goofy. As I said, this is difficult, right? We're breaking it down as far as you can. You're circling it. You're writing down what you circled. But the last step, how many 2's did you have here?
2.
You have 2 of them. You have to write it like this. 2 to the second power times 5. That is the correct prime factorization. Nicely done. All right, so 2 to the second power times 5. Because if I had 3 2's here, if I had 3 of them or 4 of them, then you're going to put 2 to whatever power you had. There was maybe 3 or 4 of them, so I put a 4 up here and then times 5, whatever that is. This is what I want the answers to look like, but I want to see all of this. That's why this can take a while. Okay, should we try another one? Okay, let's try another one. Yeah. Just put it right here. That way I can leave those primes and colors there. All right, let's try the number. Let's see. Big number, right? All right, now usually we have a calculator out, so if you have one, you can take it out. If you need one, I'll give you one here. This usually takes a calculator or 2. Anyone want to borrow one? There you go. Alex, you want one, or Sean, you want one? No. Okay, perfect. All right, so 120, what's the first prime number I should check?
2.
Always 2. Start with 2, if it goes in there or not. If it gives you a weird decimal, it doesn't work. So we're going to try the number 2, right? All right, so 2 times what? 2 times what? Sorry.
12. Oh, no. Yeah.
60. All right. That's okay. You confused me there for a second. All right, 2 and 60. Now, the prime number is on the left. The composite number is on the right, and 8. Now, is 60 composite? Yes, because 2 goes into it. So we have to keep going. We're going to break down 60 again. So, what number do I always check first? 2. 2 times 30. Okay? Are we done yet?
Nope.
No, because 30 is definitely not prime. It's not even one of the numbers I have on the board yet. So we have to keep going. So we're going to try 2 again. So 2 times 15 gives you 30? Now we have to keep going because 15 is not prime. If I check, it's on the composite list. So we have to keep going. So now, 2 definitely doesn't work anymore. So we have to move to the next number and try the next digit, which is what? 3. It's 3 times 5. And 5, since that was a prime number, we're done. So now we have to circle all of them. So we're going to go and we're going to circle all the prime numbers all the way down to the 5. Now it looks like a big hockey stick. Okay. So, yeah, so say it.
2 to the second power.
Not second, but
2 to the third
third power. Yeah, there's 3 2's there. Yep. So your final answer is 2 to the third power times 3 times 5. Okay, we'll come back from lunch. We're going to try 2 more of these, and then I'll give you time to read more of the worksheet. Not bad. That's pretty good for today. I was worried about this topic. Yeah, this is, at least some of them are like, they're on it. So, this is one of the harder topics we have to talk about.
then. Yep, so.
Welcome, buddy.
That's what I thought too. Nothing. What was? What?
Mirror was Ryan's question.
What?
Hard.
What?
Remember?
That- Oh, dude, the car dude. What was I gonna put that?
The only time I ever got it flipped was because I dropped the calculator.
What do you mean?
Did anybody take the test over?
Huh?
Oh yeah, I'm gonna let that.
What test?
English test? Or a vocabulary?
Oh, I'm still math test.
I'm guessing nobody.
Alright.
You guys will have a vocab test today.
Hey, why?
Because she told me you guys will do that and then you'll work on this.
So we're not.
You are taking it, yes.
Oh,
Yeah, you will have it.
All right.
I know the word.
Okay, so right before lunch, what we're talking about is bringing prime factorization for the 120 here. So remember, you always try 2 first out of the prime numbers and write down whatever's left when you divide it. If that works. If it doesn't, then you move to 3 first, or if 3 doesn't work, try 5 or 7 or 11. And then what you do is you write what's left. And if this keeps going, then you circle all the prime numbers that you had, and that makes this list. And then again, how this works is that since I had multiple 2s, I combine those to make 1 2, but you put how many you had. You had 3 of them, because that's what it literally means. Power of 3 to the cube means 2 times 2 times 2. Okay. All right. Questions, comments, concerns on that problem? All right. Let's try. We're going to try 2 more, and then we're done for today. 2 more. Okay, same exact rule. We're breaking down numbers into prime numbers. So let's try. I'm going to try a bigger number here. Let's see. All right. So this is my number. I know it's big, right? So, again, prime numbers. What number should we check first? 2. Now, looking at that problem, will 2 work?
No.
No, why not?
Because it doesn't end.
It's not even. It doesn't have the 0, 2, 4, 6, or 8 at the end. So, let's move on. Let's try the number 3. I don't know if 3 will work. This makes 6, 13, plus 5, 18. 3 will work. So 3 most definitely works. So, all right. So we're going to try 3. What's 1575 divided by 3?
525.
525, is that right?
Yeah.
Okay. Now, if I'm going to check this one more time, so this number definitely has a 5 in it for sure, but let's check the 3. That has it to be 12. Yeah, so it'll have a 3 again. Because again, I'm adding the digits to make sure that 3 goes into it. Okay, so we're going to try 3 one more time. So, 525 divided by 3.
175.
175. All right. And now 175, if I add up those numbers, that gives me 13. 3 definitely doesn't go into 13. So now what we need to do is we need to resort to 5s. Because I know it ends in a 5, so I know a 5 will go into it at least. So, 175 divided by 5. 35. And I know 35 keeps going. I believe it has a 5 in it again. So let's try 35. Let's break it down into 5. 5 times what?
6. No, 7.
7. And 7's prime. So it looks like we've done our job. We've broken this thing down all the way until you can't go any further. So this is the prime factorization. Looks like a big hockey stick or a tube sock or however you want to do it. Croquet mallet. Okay, so what are my numbers that you see across? So say these out loud.
You do the second 5 to the second times 7.
Good. Yeah, you're absolutely right. 5 is 7. So that's 3 to the second power, 5 to the second power, and 7 to the first power. Okay, not bad, right?
So once you like skip a number, so like 2 didn't work, so we went to 3. Will you ever be able to use 2?
Not again.
Okay.
No.
So once you
That's a good counter because if 2 didn't work at the beginning, it's not going to work for the rest of the problem. That's why I go in order. I try 3s first until 3 fails, and I know there's no more 3s anymore. So I want to try 2s and 3s if ever again. So then I'll work with 5 5s. 5 doesn't work, I try 7s. 7 doesn't work, try 11. You keep working with that one number until it doesn't work anymore, move to the next one. And you only stop when you hit a prime number at the end.
Well, could you have done 5 the whole time?
I could have done 5 from the beginning, and you would have won at least 2, and then you could have won 3. I always start with the beginning numbers, like 2s, 3s. And if those don't work, then you move to 5s. Yeah, because it would have worked if you tried 5 at the beginning. It's just, you would have only went for like 2 of them, and then there would have been a bunch of 3s and 7s at the end. So, I just like to go in order. Just kind of easier that way. Okay, I'm going to give you one number, and I'll let you try it by yourself. Okay? I'm going to have you try one number by itself.
Oh, we have to make up the number 2?
No, I'm going to give you the number. All right, here we go. All right. 4928. 4928. And I'm going to let you try this one by yourself. Let's see if you can break it down into prime factorization without me guiding you through it. Because I think we've done quite a few of these now. Okay, we give you a little bit of time. I'll give you 3 to 4 minutes. Okay. I'm going to step out.
tell your numbers. How are you supposed to get them?
So let's get the original number
We
back.
got time.
So hey, here's a quick check before we start. If you didn't hear hand, when you get down to this in the very end, and you have this, if you write this out and you type it in your calculator, it should give you the number back again, whatever yours was. If it doesn't give you that number, you did something wrong here, or you circled the wrong numbers, you forgot one. You got to circle like one of the other numbers. We're only circling the prime numbers. Prime numbers are on the left, except for the very last number. Okay, so double check. Here's another quick check. You should have had 8 numbers total. In that area.
5. And I still got it.
Then you didn't go far enough.
I had 9. I started with 2, 3 didn't work, and I got 4. 5 and 6 didn't work, and I got 7. And then I went to 8, and then I
said
9 and
8?
10.
8 numbers. There's 8 digits. There's 8 prime numbers going down. And they're not different. Some of them are the same number. There's 8 of them total. Oh, yeah. One of your numbers can go further then. Maybe it's the last one. Oh, yes. All right. Okay. Let's try this out. So, all right, for somebody who thinks they got it right, what was the first number we got? So, Colt?
Like when you
When you first break it.
2,464.
Like that? 2,664? Okay. Is that what everyone started with?
Oh my god.
Yeah.
Okay. All right. So that was the first number. Now, we have to break this number up further because 2 goes into it again. 2 and?
Oh, that's what I thought.
232.
Okay.
Yeah.
Now we keep going. So we're going to break this number up.
16.
We try it again. So it looks like I'm running out of space, but we'll keep continuing. 308. Okay.
104.
2 and this breaks up to be 2 and what?
104.
104.
I got
80.
150.
I got
154. Maybe that's where you're wrong.
Oh.
Hey, there you go. All right, so we're at 2 and 154. That keeps going further, so now I'm here. So I'm at 154. That keeps going to be 2 and
I got 88.
77. Okay.
Yep.
77 makes sense. Then we're gonna, looks like for sure 2 will not go into 77. If I add 7 and 7, that makes 14. 3 doesn't go into that. 5 definitely doesn't go into that. But 7 does. 7 and 11.
Oh, yeah.
7 and 11. That should be your last prime. So when I circle them all, if I actually circle these, and these are where it would continue down, right? Over here. Yeah, if I actually had enough room. Now, what is this final answer when I actually write this out?
2 to 6 times 7.
I thought
Times 7 times 11. And there should be 6 twos. 1, 2, 3, 4, 5, 6, and the 7 and the 11. So there's 8 total numbers there that I circled out. There's 6 twos, 7, and 8.
got it right.
Okay, there you go. That's the idea. Okay, we're done for the day. I just want to make sure we got the practice with this. Now, obviously right now, you have no idea what this is going to be used for. This is a huge tool that we're going to use for the next couple times, or next couple sections. That's why it's important. That's why I'm giving it to you now. Okay, Monday we'll probably continue, but we might see the second section why we use this. Like what our first reason is. Okay? All right. For the rest of the time is yours. You can work on that worksheet. 2.6. That's the one where you had to create numbers and tell me yes and no's for the different factors.
When is it due again?
That is due Monday.
Good.
Due Monday. Now Monday we also have you need your Chromebooks for maps testing. So Monday you'll come in here, make sure you have them right when you walk in. The desks will not be like this. They're going to be in those big rows like you saw when you walked in. Just come and sit down anywhere you want. Okay. Hopefully your computer will be charged when you walk in here because I only have like 3 sockets.